What's up everyone, welcome back, Patrick here, and in this next video we have to take this expression here and simplify it. So notice we're multiplying two rational expressions again. And first thing you want to do with this is make sure everything is factored. So starting with the numerator, we have 9x squared minus 16y squared. So notice that that's a difference of squares there, right? We can rewrite that as 3x to the power of 2 minus 4y to the power of 2. Difference of squares. So that would be 3x minus 4y, 3x plus 4y. Like that. And then we have 26x cubed minus 64y cubed. Notice that that is a difference of cubes. So if you remember, the general formula for a difference of cubes is a cubed minus b cubed. And that's going to be a minus b, a squared plus ab plus b squared. And so the 27x cubed minus 64y cubed, notice we can rewrite that as 3x to the power of 3 minus 4y to the power of 3, like that. So notice that the a is like 3x and then the b is like the 4y. And so then all we have to do is just take those values for a and b and plug it into the formula. So we'd have a minus b, which would be 3x minus 4y. And then we'd have a squared, which would be 3x squared, which would be 9x squared, right? You got to square both the 3 and the x since they're multiplying in the bracket. So this would be 9x squared plus a times b, 3x times 4y would give us 12xy. And then b squared, 4y squared in brackets. 4 squared is 16. And then we have the y squared. Then this bracket doesn't factor any further. So this expression factors into that. So if we write that at the bottom, we'd end up with this over here. And then moving on to the next rational expression, notice that we have 18x squared plus 24xy plus 32y squared. So notice out of everything, we can actually take out a 2. And so we'd have 9x squared plus 12xy plus 32. Or no, sorry, plus 16y squared, like that. And actually, this bracket here, it doesn't factor any further. So if you took 9 times 16, that would be what, 144? There's no numbers that multiply to 144 and add up to 12. Right? So this here, this bracket, it doesn't factor any further. But if you notice, it's actually going to cancel out with this bracket eventually, so that's going to be nice. But this doesn't factor any further. Now, what about this bottom expression? 9x squared plus 24xy plus 16y squared. Notice we can't take anything out, but this actually does factor because 9 times 16 is 144, but now the b value is 24. And there actually are two numbers that multiply to 144, add up to 24. What are they? It's going to be 12 and 12. Right, so if we were to factor, let me do it on this side here, 9x squared plus 24xy plus 16y squared, what we would do is, because there's two numbers that satisfy these two conditions, we could decompose that 24xy into 12xy and 12xy. And then we have plus 16y squared, and then from, now we factor by grouping, so from these two we could take out a 3x, so we'd be left with 3x plus 4y. And then from these two we could take out a 4y, so we'd be left with 3x plus 4y. And then notice this bracket are the same. They should always be the same if you're factoring by decomposition, right? If these two conditions all pan out. This and this should always be the same. So we could take that out, and we'd be left with 3x plus 4y. And notice these two are the same bracket, so it's actually just 3x plus 4y squared. Right? It's a perfect square trinomial. So that would be that. And then from here, we factored everything. Let's get the restrictions before simplifying. So notice the restrictions. We can't get any restrictions from here because it's going to be hard to isolate for the x or the y. But we can get restrictions from here. So notice that 3x minus 4y can't be 0. And here you need to just pick whether you're going to isolate for the x or the y. Same thing here. Notice that the 3x plus 4y can't be 0. So if we isolate for the x, we bring the negative 4y over, divide by 3, we would have x can't equal 4y over 3, or 4 over 3y. Same thing here, x can't be negative 4y over 3, because when we bring this over, it becomes negative. So if you isolate for the x's, those would be the two restrictions. Right? Notice that they're the same, just a different sign, so you could actually write it like this as well. But some solutions may isolate for the y, which is also a possibility. So if you did that, you'd bring this over, divide both sides by 4, then you'd have y can't be 3x over 4. Y can't be negative 3x over 4, right? Or y can't be plus or minus 3x over 4. So usually if you're looking at solutions for a question like this, and it's a mixture of x and y, the restrictions are either going to be in terms of x or in terms of y. All right? So if you, for example, do it in terms of x, but then the solutions do it in terms of y, you didn't necessarily do it wrong. Just make sure that if you were to do it in terms of y, you get the same restrictions that the textbook does. All right, so those are the restrictions. And then from here, we just have to simplify, just cancel stuff out. So notice this and this cancel out, this and this cancel out. And then we have a 3x plus 4y, and then 2 of them here, so one of them cancels out. So what would we be left with? 2 over 3x plus 4y. So that would be the final solution. That doesn't simplify any further. So that's the answer. Those are the restrictions.